Hi, okay, Assalamualaikum and good day everyone. Okay, so today we will proceed with the new topics. We are still in chapter 1. Yes. And this is another topic in chapter 1, which are chain rules and also implicit differentiation. So these two topics we will cover for this week 4. Okay, I will start first with chain rule. Okay, chain rule. I think most of you also already learned chain rule before. Okay, maybe it's just for 2 variable, but for our syllabus now, we will extend it until up to 3 variables. Okay, and then after we finish chain rule, I will proceed with the implicit differentiation in the next video. Alright, so without further ado, we start with chain rule first. Okay, as we know that chain rule is a method or is a formula that we will use for differentiating what we call the composite function. Okay, composite function means they have more than one function, more than one variable, and also like I said before, it will extend until 3 variables and so on. Okay. So I will brief first the general concept of the chain rule. Okay, the general theorem. So I will consider Z is equal to FUV. Okay, let's say we have a function of Z that consists of 2 variables, which is U and V. Okay, such that U is a function that consists of variable X and Y. And V is a function that consists also of variable X and Y. Okay. So then both the function G, X, Y here and also FUV is a function that can be differentiation. Okay. It's something function that can differentiable. So what we do is, okay, you can see that we have three functions. Okay. So we start with Z first. Okay, we start with Z. Okay, so if you can see here, Z is equal to FUV, is it? So F is your function, U and V is your variable. So means that in that function, it lies 2 variables, which is U and V. Okay, so you write down here UV. Okay, UV. Alright, so then U and V. Okay, U, inside U, they have a variable X and Y. Same thing for V, they have also variable X and Y. Okay, and this one, we call it as a tree diagram. Okay, tree diagram. So the first step when you get a question regarding a chain rule, what we need to do is you need to draw your tree diagram first. So how to draw tree diagram? Okay, you need to refer to the function or to the variable that exists in the question. Okay, step by steps. We start first with the what we call the main one. The main function here is Z, and then inside Z you have U and V. So you substitute U and V here. Okay, so now you can see the line here, right? Okay, so from Z to U, we will differentiate. Okay, so it will be dz du, and how about this line? This way will be dz dv. Okay, then you will do the same thing for the rest. So if here is U and here is X, so it should be du dx, and here is U, this one is Y, so it will be du dy. So you just fill up. Okay, fill up all the what we call the line. Okay, so now you already complete your tree diagram. Okay, so this is for 2 variables. If you have 3 variables, so just do it the same thing. Like for example, let's say you have Z is equal to RST, for example. So means that it will start with Z, and then you will have 3 lines here, which is R, S, T. Okay, so it's nothing, tak ada benda yang what we call complicated. it just depends on how many variables that you have, and then you just extend the tree diagram. Okay, the size of tree diagram lah will be extend. Okay, alright, so this is a tree diagram. So then we will proceed with the example. Okay, so in that example, in this example, I will show you how to answer or how to solve. Okay, how to solve the chain rule. So example 1 here. Okay, use the chain rule to determine. Okay, to determine dz dx and dz dy if z is equal to u square plus v4, where u is equal to x square cos y and v is equal to x y cube. Okay, so this is a question. Okay, so now the question asks you to find dz dx and also dz dy. So we already clear that we want to find out which differentiation. Okay, so the first thing first, you need to draw a tree diagram. Okay, so by refer to the function here, so this is the main function. Okay, z is our main. Why I say it's a main? Because inside z here they have u and v. Okay, so means that z is the main one lah. Okay, so z is the head ataupun dia punya subject. Okay, and then under z they have a variable u and v. Okay, then under u, okay, they have another two variable which is x and y. So x and y, same thing for v. So we have x and y. Okay, so now, okay, then just fill up lah. Okay, kalau ni you can fill up this branch. So dz du, du dx, du dy, dz dv, dv dx, dv dy. Okay, now we go to the question. The first one, the question asks you to find dz dx. Okay, so what I mean by dz dx, so it start from x, it start from z, of course, okay, because the z is the head one, and then we must end with x. So maksudnya dekat tree diagram ni, from this tree diagram, you just refer to the line or to the branch that end with x. So kalau tengok kat sini ada 1, 2, 3, 4, maksudnya x, y, x, y. So we will choose the line that end with x. So these two, is it? So then, okay, I have another pen here. So then what we do is, okay, maybe you can circle up this line. Okay, this one the first line, and this is the second line. Okay, so you can see that at the first line we have dz du. Okay, dz du. And then from this one, from this line to this line, we will multiply. Okay, we will multiply. So it will be du dx. Okay, so we finish for this first line. So now we go to the second line. So from this line to this second line must be sum. Okay, tambah, addition. Okay, summation, addition, tambah. Okay, so we do the same thing. So we start first with dz dv, and then from this line, okay, this one to this one will be multiplication. So we will multiply with dv dx. Okay, right? So this is how we get our formula or our equation for dz dx. Okay, so now you need to fill out lah, of course lah, bukan tinggal macam ni je. So what we do next? We will find a differentiable for dz du, du dx, dz dv, dv dx. So we start first for the z du. So means that you just refer to the equation z here, and then you will differentiate with respect to u. So with respect to u, what we have here? We have 2u. Okay, then du dx, so this is u equation. So you will differentiate this u with respect to x. So you have 2x cos y. Okay, then plus, okay, you do the same thing equation Z, but now with respect to V. Okay, with respect to V, so we have for V cube, and the last one Vx. So differentiate equation V with respect to x, so we have Y cube. So okay, now this not finished yet. Okay, what we do next? Your final answer must be only contains or must be exist only variable x and y. Okay, why I say x, y? Because okay, you can refer to this line or this row. The last one will be x, y, x, y. So means that at the last or for your final answer, it just only consists of x and y. They have no more u and v. Tak boleh ada tak boleh ada u and v. It must be x and y only. Okay, x and y only. So what you should do? So you will replace like this, and you have u, you have v here. What we do is just substitute u and v what we get from the equation. Maksudnya daripada soalan tadi you dah ada u, equation u and v. So we just substitute the equation. So now I will replace u with x square cos y. Okay, and v I will replace with xy cube. Okay, and then you simplify lah. So they have 4x cube cos square y plus 4x cube. Okay, this one 3 power 3 will be 9. Okay, 9. Okay, 3 power of 3, 9. So so okay, I write first this one y9 and then times with y cube. So this 9 and this 3 you will add. Okay, tambahkan, bukan darab. Ni akan jadi tambah. So it will be y power 12. So this is the answer. Okay, this is the answer. Okay, so we just finished for the first one with dz dx. So now we will go to the second one, dz dy. Okay, dz dy. So we just refer to the same tree diagram. Okay, we will use the same tree diagram, but now our line is no longer this one and this one. It will be the new one, which is this one and also this one. Okay, so I will write here. So it will be dz du dy plus dz dv times dv dy. Okay, can you see the difference here? The difference here is only this term. Okay, this one is du dy, this one is dv dy. Just now, our example just now, dz dx will be du dx and dv dx. Okay, so means that you tak perlu nak calculate yang ni lagi. For dz du, you just take it. So it will du, 2u. And for dz dv also is the same thing for v cube. Okay, so now the new one that you need to calculate or you need to find out du dy. So what is u du dy? So differentiate u respect to y, so negative lah, kan? Betul tak? Negative x square sin y. And how about dv dy? 3x y square. Okay, 3x y square. So simplify lah dulu kot. Okay, so negative 2ux square sin y plus 12v cube x y square. So you do the same thing. You will replace u with x square cos y. Okay, and then v you will replace with xy cube. Okay, so and then simplify. So negative 2x4 cos y sin y plus 12x cube x4, okay, x4, y9, y11. Okay, so this will be answer. Alright, easy, right? Senang kan? Okay, so okay, I will give you one more example. Okay, one more example before we stop our before we finish our topics for the chain rule. I will give you another one example. Okay, example 2. Okay, suppose that w equal to xz plus yz with x equal to r plus 2s, y equal to r, z equal to negative 3s. Okay, now the question asks you to determine dw dr and dw ds. Okay, so first thing first, you need to draw your tree diagram. Okay, so we start with w, and then inside w we have x, y, z. Means that we will have three line or three variable, x, y, z. Okay, now for x they have r and s, so r, s, and for y they have only r, for z they have only s. Okay, it's simple. Maksudnya tak perlulah dua-dua tu kena ada macam ni kan. X you have r and s, but y you just only have r and z only have s. So just follow the equation. Tak perlu nak buat yang tak, maksudnya kalau r ni janganlah pula buat satu lagi branch which is s. Jangan, okay? Just follow the equation given, okay? Alright then, so you can fill up lah, okay? dw dx, dx dr. This one is dx ds. dw dy, dy dr, dw dz, dz ds. Okay, so now the question asks you to find dw dr. Okay, dw dr first. Okay, so dw dr, which line? This one and also this one. Okay, so dw dx times with dx dr plus dw dy plus dy dr. Okay, alright. So now you need to find out lah all these all these four terms. So dw dx, so dw dx is equal to z. Okay, dx dr, dx dr only one. dw dy, dw dy will be z. dy dr, so it will be 2. Okay, z plus 2z is equal to 3z. And like I said before, your final answer must be consist of the last variable only, that appear in your tree diagram, which is r and s. So means that z is cannot be longer here. Tak boleh ada z. Okay, cannot be appear z here. What we do is just replace z with the equation given here. So 3 z equal to 3s. So the answer, the final answer will be negative 9s. Okay, the final answer will be negative 9s for dw dr. Okay, so the last one is to find dw ds. So just refer to the same tree diagram. So now the line will be these two. Okay, so just fill up. Okay, so we have dw dx. Okay, then dx ds. Okay, plus dw dz plus multiply dz ds. Okay, so just fill up. So dw dx just now is z. Okay, dx ds. Okay, dx ds. dx ds. So it will be 2. Okay, plus dw dz. So it will be x plus y. Okay, dz ds negative 3. Okay, so this one 2z, this one will be negative 3x negative 3y. Okay, so now this z, okay, you need to replace. So 2 become negative 3s. Okay, x will be replaced with r plus 2s, and y will be replaced with 2r. Okay, simplify. Okay, simplify again. So they have negative 12s, they have 9r. So the answer is negative 12s minus 9r. Okay, alright. So this is all about chain rule. Okay, it's simple. Okay, but make sure you draw a correct tree diagram lah, because I think if you do wrong tree diagram, okay, maksudnya you punya line tu dah salah, means that you will differentiate the wrong one lah. Okay, the wrong term. Okay, so make sure lah careful. Okay, and don't forget to replace your final answer. I mean the final answer must be consist of the variable that the last variable that appear in your tree diagram. Okay, because of most of us most of the students will be just leave it the answer until here. For example, mostly. Okay, so careful. Okay. Alright, so we finish on the chain rule. So the next video I will explain on the implicit differentiation. Okay.